Previously, we learned about global winds. Today, we're going to learn about local winds and regional winds. It is global, large-scale, high and low pressure cells that create global winds. So to create local winds, you're going to have local highs and local lows. And to create regional winds, you'll have a regional low and a regional high. We will look at sea breezes and land breezes as our example of a local wind. For your understanding, I always think it's helpful if we draw these out together. So draw your version of water, your version of land, and then add a sun to the top of your diagram. Before we get started, I like to point out that if I would have explained sea breezes and land breezes on the first day of class, it probably wouldn't have made much sense to you. But because we've been learning about highs and because we've been learning about lows and we're beginning to understand wind, this process should feel fairly simple to you. And let's have a quick reminder of some of the rules with regard to wind. We know that air always moves from high to low pressure, and we know that highs are formed over cool surfaces and lows are formed over warm surfaces. That should be enough information to get us started on sea breezes and land breezes. The sea breezes and land breezes are a diurnal process. That means that these winds occur every single day. Remember the 5-star rule about water and land differences? That land heats and cools faster than water? So if it's 3 o'clock in the afternoon, which is going to be warmer, the land or the water? The land will be warmer and the water will be cooler relative to the temperature of the land. These two surfaces heating at different rates will create variable high and low pressure. So what will form over the land? A high or a low? What will form over the water? A high or a low? The warmer land will create low pressure and the cooler water will create relatively higher pressure. Now, does that mean that it's going to rain over the land down at the beach every single day at 3 o'clock in the afternoon? Absolutely not. This is just a temperature low, a thermal low, due to the variable temperatures of these surfaces. Air always moves from high to low pressure, creating a sea breeze or an onshore flow. Now draw another water and land, but this time draw a moon because we're going to speak about the process that happens in the evening. In the evening, relative to each other, which is warmer, the land or the water? Relatively speaking, the water is warmer than the land. Remember the rule that water heats and cools more slowly than land. Because of this, the water temperature is actually the same temperature as it was during the day. But because land heats and cools more quickly than water, remember that the land temperature at 3 o'clock in the afternoon was super duper warm, and by the evening, the land temperature is cold. This makes the water temperature, relatively speaking, warmer than the temperature of the land. In the evening, where is the high pressure cell located and where is the low pressure cell located? The warmer water will create low pressure and the cooler land will create high pressure. Air always moves from high to low pressure. This creates a land breeze or an offshore flow. Next, we will look at the monsoons that affect India as an example of a regional wind. While sea breezes and land breezes represent a daily reversal of the winds, monsoons represent a seasonal reversal of the winds. To better understand monsoons, let's locate India on a map. India is in South Asia, and a large portion of it is sandwiched between two important seas, the Arabian Sea and the Bay of Bengal. Let's also draw this diagram together. Draw your version of India and be sure to include the surrounding seas. As you're doing that, let's make sure we are very clear about something. For there to be a reversal of the winds, that means that there must be a reversal or a flip-flop of the high and the low pressure cell. In this case, that happens seasonally. Let's first understand what happens during the summer. Think about where we started with the sea breezes and land breezes. We have to figure out which is going to be warmer, the water or the land. In the summer, the land will be warmer and the water will be cooler. The warmer land will create low pressure and the cooler water will create high pressure. Air always moves from high to low pressure, creating that onshore flow, and that low pressure brings the wet season to India. Okay, let's draw another India. Don't forget the surrounding water, but this time label it winter. In the winter, what's going to be warmer, the land or the water? Relative to the land, the water will be warmer and the land will be cooler. The relatively warmer water will create low pressure and the relatively cooler land will create high pressure. Air always moves from high to low pressure, creating that offshore flow. A high pressure brings a dry season to India in the winter.